So we almost getting close to the end of this semester, and we need to decide when we are going to take a final exam. And originally, I was thinking about having a final on June 12th, but some students have some difficulty in that day. So I have two options. So June 12th. So there's my schedule. So we have two options. One is the last class will be June 5th. And June 12th, I have two options. I'm considering two options for you. So June 12th, my student, your TA, Mr. Sang-won Park, will provide a solution how to solve the problem for the previous quiz and also previous final problems for maybe 3 hours. So, right? In English, it's okay. Right? Because he's supposed to give a talk in Taiwan anyway. So this is a good practice for him to practice in English. And June 19, we're going to go final exam. And another is skip the problem solving session and go straight to final. I think first option may be good for you because some of you are still not quite confident about some kind of problems like polarized composition, for example. And so maybe you may be better prepared for the final. And June 12th, there's a final. Another option is there's 1 week to prepare for the final week, so maybe give you time to prepare for other subjects. So that's another advantage of that. So, and either way, the final class is June 5. So, anyone who favors option 1, raise your hand. Or just skip the problem solving session and then go straight to final. Well, I guess good for you. So June 12th is the final. Sorry. So we have to think about something different. So final will cover from beginning to end. Alpha to omega. beginning to end. And there won't be no more quiz. And so 12, we'll just skip the class and just you prepare for the final. Oh, no, 12, we are going to have a final, right? So no skipping class. So linear algebra. So linear algebra covers determinant, eigenvalue problems, spectral theorem, and the culmination of those. So everything can be combined together into a polar decomposition, right? So polar decomposition requires knowledge of determinants and finding the eigenvalue and eigenvectors and also the use of spectral theorem. And this time there is a possibility of finding the polar decomposition for 3 by 3. So possibility exists. 3 by 3 polar decomposition. And then second topic will be differential equations. So that include logarithmic derivative. So definitely one problem in logarithmic derivative, and that can be as complicated as this time. And then maybe finding the general root. Fine. Homogeneous equations and determining the coefficient. There's one set of problems that I can ask. And starting today is a inhomogeneous equation. That we are going to cover today, and Laplace equation. Next week is 29th, and one more week. So I haven't decided the topic yet. So 3 more topics will be covered. Maybe Laplace equations. Laplace transform, not equations, transform. And probably Fourier series. that we will see how we proceed. So the topic is inhomogeneous ODE. So assuming they have a differential operator, L is A0x dxn dn it's the most general form of a differential operator. The first step is finding the homogeneous solution. So in this case, YHX. If the differential operator is applied on YHX is 0, then it is called homogeneous solution. But however, there can be some S of x. If it is non-zero, then it is called source term. Then, if the right-hand side is non-zero, it's called inhomogeneous equation. Then, in that case, the homogeneous solution is also still a solution. So Yx can be YHX plus YPS. It's called particular solution. Particular solution. Because and this is still 0, right? So, because YH is started as a homogeneous solution, so if you apply this actually came from this, right? Particular solution. So this YH is the original solution of this differential operator. So, and if you have new problem that such that if substitute L by Yx is Sx, then the solution can be still composed of two components. One is homogeneous part, and the other one is inhomogeneous part, because if you substitute this YH back into this is again still 0, right? So if you add something to the 0, still it doesn't change. So this is Sx. So let's consider this particular case. For example, so step 1 is finding the homogeneous part. So we have considered 2 different cases. One is when PQR was constant. Another case was PQR was equidimensional, x squared, x or 1. So for these 2 cases, you can find the exact solutions, right? So that means Px dx squared d squared yh1 qx dx dyh1 rx yh1 is 0. Px dx squared d squared yh2 qx dx dyh2 rx yh2 is 0, right? Because they are the solution of the homogeneous equations. So let's say this is equation 1. How about particular solution? We don't know, right? So step 2, make an educated guess of ypx. So we need to make an educated guess. And the only knowledge about we have for this particular solution, this equation is homogeneous equations, homogeneous solutions, right? The only knowledge we have is yh1 and yh2. So let's try to utilize. So we can try to utilize the null of yh1x, yh2x by assuming ypx u1x, yh1x, u2x, yh2x. u1, u2 are unknown. Do you think it's a reasonable assumption or reasonable guess that yp can be some functional form of yh1 multiplied by some unknown function plus yh2 multiplied by unknown function y2? you can guess that, right? And see what happens. So there is actually no consistent mathematical theory to deduce the form of a particular solution from the equation itself. So that's how you try to find the solution. So y1 and y2 are known. u1, u2 are unknown functions. So we like to impose one constraint. Therefore, actually this is also educated guess. And see what happens if you can solve with this constraint. But it turns out that this constraint is a really important condition to find the u1 and u2. So let's see. So let's say this is equation number 2 and continue. So we are going back. yp u1x yh1x u2x yh2x. So we differentiate once. yh2x plus u2x dx dy h2x. But this 2 is 0, right? By assumption. So before we try to find a solution, we make an assumption for the constraint such that dx du1 uh1 plus dx du2 yh2 is 0. So don't ask me why this is. This is we just set the condition. So it's the educated guess for condition. Then if we differentiate ypx, then this part this is 0, right? So the surviving term is this. Okay, can I move on or is it time to copy? So dx, dy, px, u1x, dx, du1x, y h1x, plus u2x, dx, dy, h2x. So if we differentiate twice, we have dx du1x, dx dy h1x, plus u1x, dx squared, d squared y h1x, plus dx du2x, dx dy h2x, plus u2x, dx squared, d squared y h2x. So let's substitute the back into the original differential equation. So px dx squared d squared y px qx dx dy px rx y px is px with this term dx du1 dx du yh1x u1x dx squared d squared yh1x plus dx du2x dx dy h2x u2x dx squared d squared yh2x. This is px dx d, oh sorry, I plus qx u1x dx dy h1x u2x dx dy h2x plus rx u1 yh1 u2 yh2, right? So we can combine them together. u1 p dx squared d squared yh1 q dx dy h1 r yh1 u2 p dx squared dx yh2 q dx dy h2 r yh2 plus px dx du1 dx dy h1 plus dx du2 dx dy h2 sx, right? So what happened to this part? yh1 was a homogeneous solution, right? So this has to be 0. And this is also 0. So we found two conditions for U1 and U2. Actually, TU1 and TU2. So are you following me up to now? Then it becomes obvious why we made the educated guess for the U1 and U2 in the first place. So before I proceed, let me ask, how many of you have a difficulty in getting a final exam in 12? How many students? (12일) 안 되는 기말고사 보기 어려운 사람. How many? Right. So I guess there are few students who may have difficulty in getting a final exam on 12th. And for those students, we will have a separate exam on 11th with a different set of problems. That will be okay, right? So most of you will take the exam on 12th, but if you have difficulty in have a final exam on 12th, you have to ask Mr. Park within this week or then this week. 12일 날 시험 보기 어려운 사람이 몇 명 있던데 그러면은 우리 조교한테 미리 이메일 연락을 해주면 11일 날 다른 셋 적은 문제를 시험 보게 하죠. 우리 학생 연구실에서 큰 방 있으니까 거기서 똑같은 조건에서 시험 볼 거고 문제는 다를 거예요. 전혀 다를 건데 난이도는 같을 거고 배점도 똑같이 줄 거예요. 그 정도면 페어하겠죠? 근데 문제가 다르다고 해서 먼저 본 학생들이 어떤 문제가 나왔다고 얘기해 주긴 없지. 그래서 그 12일 날이 곤란한 학생은 미리 연락을 해줘요. 우리 조교한테. 그러면 따로 몇 명 인원을 파악해 따로 볼 거니까 11일 날 시간은 따로 정해서. Okay, so we have two conditions. So actually, it looks like we need to find this condition one, right? So can I move on? So dx, px, u1, dx, dyh1 plus dx, du2, dx, dyh2 is sx. Another condition was original one, right? dx, du1, yh1, dx, du2, yh2 was 0. That is the condition that I artificially imposed. It's a condition imposed earlier. Then this we have two equations and for two unknown dx du1 and dx du2. So we can solve this, right? 2 by 2 unknown. So let's solve this. So yh1 dx du1 yh2 dx du2 is 0 and dx dyh1 dx dx dyh2 dx du2 is sx divided by px. So now you are familiar with the inversion of a 2 by 2 determinant. YH1, YH2, dx dyh1, dx dyh2. So anybody remembers the formula for inverse? A11, A12, A21, A22. So final is coming near, so you should remember how to find the inverse matrix, right? So what is the inverse? Inverse matrix, remember? 1 over, right? A22, A11, minus A12, minus A21, right? Oh, so final exam also include finding the inverse as well. So that's the inverse. You remember, or you forget. Anyway. Well, if you remember this formula, it's very convenient because finding 2 by 2 unknown linear equation is quite common in many engineering problems or many other engineering or science problems. So from this, inverse is, oh, I don't have enough space. Never mind. Maybe, can I move on? Too fast? Or maybe you can take a break and then continue?
기말 시험 보니까 전체론이랑
예.
그 중간고사 때 쳤던 거, 퀴즈 때 쳤던 거
전부 다 플러스 지금 배우는 거.
지금 배우는 거까지.
5일까지 배울 것까지.
현재 그 대기실 유도가
goes like that. A here with the previous case. This is our 2x2 equation. I may need to change the battery. Okay. So So before finding an inverse, so we need to find the determinant. Determinant A is actually yh1x dx dy at2x minus yh2x dx dy h1x. It has a name called Wronskian. The determinant in this case is called the Wronskian. Then A inverse is 1 over Wronskian x dx dy h2 minus yh2 minus dx dy h1 dx dy h2 yh1. Oops. yh1. So our original problem. So since the problem was A dx du1 dx du2 is 0 sx divided by px, right? Compare with, if you dx du1 dx du2 is nothing but Wronskian times dx dy h2 minus yh1 minus dx dy h1 yh1 times 0 s over p. For convenience, let's put this way. yh2 prime is, okay, to save the time and effort. So u1 prime, u2 prime is actually 1 over wx, and you multiply it by this and this, what do you get? Minus p s y something is different. This is 2, right? So yh2, and bottom is p over s yh1. So u1 prime is actually px wx sx yh2x. u2 prime is plus px wx sx yh1x. So we are almost there. Can I move on? Okay. You see the time? I guess my problem is writing too fast. So let's move. Oh, let's be consistent. So u1 prime is actually wx, px, sx, and yh2x, right? u1 is, you can just put this integration. And u2 prime is wx, px, sx, yh1x. u2 is same as wx prime, px prime, sx prime, yh1. This is 2, 1, x prime, tx prime. And then particular solution is this yh1 x sx prime yh2x prime wx prime px prime tx prime plus yh2x wx prime px prime s. This is minus x prime yh1 x prime tx prime. So general solution will be yx will be c1 yh1x c2 yh2x plus yp. So that's the reason why, that's the reason why I didn't put plus c here, because this c will be again absorbed by here. So it's just an indefinite integral. Or can I move on, or still? So I can put it down. C1 yh1x plus c2 yh2x plus yh1x actually is minus So for the second order general inhomogeneous equations, that's the general solution. And for higher order, you can do the same thing, but it's very complicated. So let's skip that. And one can apply the same method to higher order inhomogeneous ODE, but it's outside of our topic. But the topic for this semester. It's good news for you, right? But I can just describe the idea. For example, if the third order or nth order differential equation for example, nth order a0x a1x nx y equals s6. Step 1, you find the n homogeneous solutions, right? Step 1. This is not the topic for final, but I'm just going to describe the method, just in case. For you, if anyone who is curious about finding for higher order solutions. So yh1, yh2, we will have n homogeneous solutions, right? And then particular solution will be yp u1, yh1, u2, yh2, un, yhn. Constraint, condition. The first condition will be u1 prime, yh1, un prime, yhn equal to 0, right? And then you substitute it back into the equation, then you will find the condition for something. And then find n minus 1 conditions. But very difficult. I would say it's a very difficult problem. So you don't have to worry about this. So let's do some example. Can I move on? Can I move on or you still need time? I can move on? Okay, 1 over cosine x. This is one of my favorite example. You still need the time? So part 1, homogeneous. This case is easy, right? dx. Yeah, 0. So we have done this. So yh1 is cosine x, yh2 is sine x. So let's try to find the Wronskian first. Cosine x, sine x, minus sine x, cosine x. Wow. That is cosine square x plus sine square x is equal to 1. Good news, Wronskian is 1. Also, px is 1 too, right? So u1 is actually minus Wronskian 1, 1, 1, but secant cosine x, sine x, dx, right? So this is same as this cosine x, d cosine x. So it's ln cosine x, right? u2 cosine x over cosine x dx is x. So general solution is I can y c1 cosine x c2 sine x plus ln x cosine x cosine x plus x sine x. So I can give you a condition for C1, y and y prime 0, and ask for so this is general solution. So I can apply, I can give you maybe y0 is 1, y prime 0 is 0, or something different. That will give you another example I like is still, maybe I'm going a little bit too fast. Example x squared dx squared d squared y minus 2y, say x. So this is a equidimensional type, right? So we set z is ln x, then dz, this L become dz, dz d minus 1, minus 2, right? So dz square d square minus dz d minus 2. So L lambda z is lambda square minus 2 lambda minus lambda minus 2 exponential lambda z is equal to 0. Or you can factorize lambda plus 1, lambda minus 2, exponential lambda z is equal to 0. So lambda is minus 1, lambda is equal to 2. So yh1 is exponential minus z ln x ln 1 over x is 1 over x, right? yh2 is exponential 2z ln 2x ln x squared. Can I move on? Too fast? I guess I still need the time to. So can I move on? Okay, so yh1 is 1 over x, yh2 is x squared. So Wronskian is 1 over x squared. Minus x squared, 2x, right? So that is 1 over x times 2x minus plus x squared times x squared is 3. The Wronskian is 3. And in this case, we have a px is x squared. So calculation is maybe a little bit tricky. u1 is minus 3x squared. And source is x. So x times yh2 is x squared, right? So minus 1 over 3, that is x dx, right? So minus 6 over x squared. u2 is 3x squared x 1 over x. dx 1 over 3 x squared dx, right? It's minus 3 x. So yp is yh1 was 1 over x, right? Minus 6 over x squared plus minus x squared 3x. So that is minus 6 over x plus or minus 3 over x over 2, right? So general solution is something like that. Y is c1 x minus 1 plus c2 x squared minus x over 2. So at least you can find the inhomogeneous case for constant coefficient and equidimensional case for second order. So I will give you some homework and so study previous quiz finals for 우리 몇 년치 올라가 있지? 다 있어. So on the if you go to the website, there will be a final exam previous quiz since 2007. So there will be plenty of problems you can solve. So maybe, do you think 10 will be enough? Maybe 20? Because I'm going to ask definitely one problem in particular inhomogeneous case. And there are many different variations, but for previous quiz for 12 years, I think there will be at least, I don't know, maybe over 20 problems. You can choose. So design and solve 20 ODE or second order. That will be homework. Homework means you just do at home. And best possible choice would be go back to the website and choose the previous exam problems. That will be your maybe good choice. Also, you can consult other books if there's good problems. And for final, you can prepare 3-page cheating sheet. Three pages. So final is 3 hours. 11 to 2. And so you can prepare 3 pages of cheating sheet. And I can guarantee that you will be very busy. So that's about ODE. So before I proceed, maybe you can ask me, you can slow me down by asking any questions. You can even ask a question in Korean too. So that's the end of differential equations part. And we are going to move on to Laplace transformation. So let me just stop thinking about the final exam problems. Inverse, right? That's a good choice. Probably 4 by 4. Make you busy. And also easy to make a mistake. Or 3 by 3, depending on my mood. I think most likely 4 by 4. There's a possible candidate. And then I'm going to ask you to problem that can combine all the knowledge of linear algebra, determinant, eigenvalue problems, spectral theorem, that together there's a polar decomposition, right? So how many of you think you got the polar decomposition problem right for last quiz? Maybe half of you, right? I think. So it's a good practice. 2 by 2 or 3 by 3? 3 by 3 will be a little bit more hard, but same. Just a bit more computation. Definitely logarithmic derivative and tautology. So it's the same thing. Maybe with the multiple root. And maybe initial conditions as well. So maybe determining C1, C2, or C3. C3 means third order. Particular solutions. YPX, right? That's what we covered today. And then we can add we have 2 more candidates. 1, 2, 3, 4, 5, 5, 6, 7. We'll make you quite busy for 3 hours. And then we're going to cover the topic soon. So topic number 6 will be Laplace transformation. So how many of you are taking electric circuit? 전기회로 듣는 사람? And are you studying Laplace transformation now or not yet? Not yet. but you will soon. So maybe this is a good time to study Laplace transformation before the course. So Laplace transformation, one way of solving inhomogeneous problem so one way of solving inhomogeneous ODE with constant coefficient. So main application is electric circuit. So let's define and we are going to use a capital letter. Y of S. Then one of the most important properties is the Laplace transformation of the derivative. And remember the integration by part that you learned in high school? 부분적분? The integration by part is 부분적분. yt exponential minus st 0 to infinity minus ds dt d that's called 부분적분. So S is non-zero. So what happens if t goes to infinity? Exponential minus st goes to 0, right? So that becomes minus y over 0 and minus of minus st. Exponential minus st yt dt, and we have some space. So this becomes minus y0 plus s dt is s minus y0. Can I move on? Someone's still writing, so I will read. Minus st. So we can continue. dt square, d square y. So we can use integration by parts. Exponential minus st, dt square, d square, yt, 0 to infinite, minus tt, t, exponential minus st, tt, t, yt, dt, right? So that is minus y double prime 0, right? Oh, sorry. This is not partial integration. This is dt, right? So that's prime t. Plus, this is s, st, tt, yt, tt. Actually, this has been done before. We know the result already, right? So this is s, ys minus s, y0. So it becomes s square ys minus s y0 minus y prime 0. Still busy writing? I'll wait. So we can continue this process. Can I move on? Okay, thank you. So, let's summarize so far. Definition of Laplace transformation is st, yt, tt. So this is called the Laplace transformation. And it is one of integral transformation. So dt dyt sys minus small y0 dt square yt is s square ys minus sy0 y prime 0, and we can make a by induction s cube ys minus s square y0 minus s y prime 0 minus y double prime 0. So you can check as a homework. So for example, so we have A0 A2y is ft. So assuming that the following electric circuit is described by this equation, then with the condition with y0, y prime 0 given, then what we can do is apply the Laplace transformation whole thing. That means Laplace transformation of A dx squared d square y a1 a0 dt dt dy a2 y is ft, right? And we are going to use t for Laplace transformation because in the electric circuit system, the derivative is taken for time. So t is the natural choice for the independent variable. So this is a linear equation. So say f over s, and this part t, right? So we can separate a0 a1 a2 y dt. So this is basically a0 Laplace transformation of dt squared d square y, a1 Laplace transformation of dt dy, at y. So a0 s square big S minus sy0 minus y prime 0 plus a1 sys minus y0 plus a2y. So we can Can I move on? So this is a0 s square y over s minus s y0 minus y prime 0 a1 sys minus y0 plus a2 y over s is fs. Or we can rearrange the following way. a0 s square a1 s plus a2 y over s minus a0s plus a1 y0 minus a0 y prime 0 is f of s, or a0s square a1s a2 y over s is a0s plus a1 y over 0 plus a over 0 y1 0 plus f over s. So is is actually a0s square a1s. Oh, this has to be written this way. S square s plus a2 over a0s plus a1 y0 plus a0 y prime 0 plus s over s a0 s square A1s plus A2. And from this ys, we can find yt. From this, we can find yt by lookup table. That means we need to have a table of functions for the Laplace transformation. And then we compare the table and then we find the solution. So maybe we can take a break for 5 minutes and then start the building table. Go back to a few more slides here. Anybody can remember this formula? Maybe I can copy. A0y prime. I think I can remember. A0s plus A1y0 plus A0y1 prime, yes. Okay? So the easiest case, 1, right? So f of s dt is minus 1 over s exponential minus st, 0 to infinity is 1 over s. T. So that actually can be calculated using integration by part. But I will give you a simpler way. What is this? Because when you differentiate by s, this is outside of the integral variable, right? T. So this is minus t. This is minus exponential minus t exponential minus st of t dt, right? Or minus tsd is same as this exponential minus st tft dt, which is the Laplace transformation of tft. This is nothing but minus tsd fs. So Laplace transformation of t is actually minus tsd 1 because this is the same, right? So this is minus tsd 1 over s is s squared. very easy. Right? I mean, just follow this. If we differentiate this whole thing by s, then ft has nothing to do with s. So it only acts on this exponential minus st, and it becomes t in front of exponential, right? Or minus dt ds is you can move t this way. So exponential minus st, tft. So Laplace transformation of tft is same as minus ds dfs. And since we already obtained 1, right? 1 is s 1 over s. So t Laplace transformation t is same as minus dsd Laplace transformation 1. Right? This is s squared. And then you can continue to obtain the same thing. So since we have some space here, so Laplace t squared is same as actually minus dsd Laplace transformation of t, right? And we obtained this minus dsd 1 over s squared s cubed over 2. And then you can continue. And maybe I was right. Lambda t. Okay. Lambda t. dt s minus lambda exponential minus s minus lambda t 0 to infinite. When t becomes infinite, 0. When t becomes 0, it's 1, right? So 1 over s minus lambda. So Laplace transformation of exponential lambda t s minus lambda. So let's try to find out solution of a Laplace transformation with this limited table. There are more tables, but we can do some exercise. So for example, so where were we? So before constructing more table, let's just try to find a solution using this simple table. So maybe I can move on. So for example, y over s was a0 s squared plus a1 s plus a2 a0 s plus a1 y0 plus a0 y prime 0, right? f over s a0 s squared a2. Let me see. Let's go back. let me check my memory. A0 is. So let's set some things. A0 is one case. A1, 3. A2 is 2. And Fs so that means Ft was what? Exponential minus 3t, right? And initial condition. Let's just, how about y0? I like to make one of them is 0 and one of them is 1. Which one do you like to make a 0? Maybe you can say first one 0, right? That's maybe easier. 0, 1, right? Then y of s is simply s squared plus 3s plus 2 and 1, right? Plus s squared plus 3s plus 2 s plus 3. This is called partial fraction expansion. So we need to find the 5. So actually we know the solution, right? So what is the solution? Yt A b exponential 2t, c exponential minus t, t exponential 2t, e exponential minus 3t, right? But of course, we need to find the a, b, c, d, e, 5 condition constant. And that actually we have done this in high school days, right? I will give you a very simple trick. The first one. There's a very simple way of so we already know the solution, but we still need to find this constant, a, b, c, d, e. So I know it. So the easiest way of finding AB is the following. Both sides. 1 and set. So first, when you determine A, you like to make 3 disappear. So what you can do is, you You multiply s plus 1 on both sides, right? Then we have s plus 2 plus a, s plus 2 over s plus 1a, right? B. And then set s equal to minus 1, what happens? 1 equal to a. And then you can do the same thing for b. This time multiply s by s plus 2 on both sides. On both sides. And set s equal to minus 2, right? So if we multiply s plus 2, we have s plus 1 equal to s plus 1. We know now a, right? S plus 2. A was 1. Plus b. So set s equal to minus 2, what happens? b minus 1 equal to b, right? So we have s plus 1, s plus 2 is s plus 1 over a minus b over, 1, 1. This is 1, 1 plus 2. And then you can do the same thing. So a was 1, b was minus 2. How about the other term? Can I move on? Same thing, s plus 1, s plus 2, s plus 3 was c, s plus 1, d, s plus 2, e, s plus 3, right? Oh, I was not using my microphone, sorry. So maybe my voice was not loud enough. So if you like to find C, what do you like to do? Make D and E disappear, right? So 1, you multiply S plus 1 everywhere and set S equal to minus 1, right? So what we have is actually S plus 2, S plus 3, C plus S plus 1, S plus 2 over D, S plus 1, S plus 3 over E. So this method may be much faster than actually what you have done in your high school days, right? So actually I invented this method when I was a high school student, and I solved this way, and my teacher froze the answer because I didn't follow the standard approach. Of course, I got the right answer. So that is 1, 2 equals C, right? So C is 1/2. Cross S plus 2 everywhere and set S equal to minus 2. So you can S plus 1, S plus 3 is S plus 2 over S plus 1. We already know the C, so it's 1/2. But it doesn't matter. D plus S plus 3 over S plus 2E. So if we set minus 2, what happens? Minus 1/2, right? Minus 1. Minus 2, right? So this is minus 1 equal D. And same thing. let's do this in a separate space. Cross s plus 3. What do you have? S plus 1, s plus 2 is actually s plus 1, s plus 3 over 1 half minus s plus 2, s plus 3 plus 2. So that's 2. We need more space here. 3. So if you substitute minus 3, what happens? Minus 3 is minus 3. Minus 1, minus 2, right? Equal to E. So C is 1 half, D is minus 1, E is 1 half. A was 1, B was minus 1. So we determined all the unknown coefficients this way. And since you must be quite hungry, maybe I can stop it today. 아까처럼 토요일 날 보는 건 별로 학생들이 선호하지 않대.
그러니까요. 그건 예상했어요.